Okay, similar solids. Similar solids, do they have to have the exact same angles?
Yes.
Yeah, they do. I mean, spheres, that's a little bit, anyway. What about sides? Do they have to have the exact same sides? No. So similar solids, one is little, one is bigger, but there has to be something true about the sides. They have to be proportional. What do they have to be, guys? Proportional. I swear we've gone over this, but it's been a few chapters back. So let's review. All right. For the first vocab word, I only want you to write down, I think, 2 words. How many words? 2. Okay, are you ready? Similar solids have equal ratios. So when you compare sides to sides, radius to sides, they have to be equal ratios. That's it. That's all I want you to remember. Okay, this picture, turns out it comes up later on in the notes. We're not going to worry about it for right now. Let's just talk about ratios. Okay, actually, I'm going to use the picture, but I'm going to draw over it. What if, we didn't know that. Check. All right. Okay, if this radius was 2, and this radius was 10, what's the ratio of radius? Perfect, 2 to 10. Simplify it though.
1 to 5.
All right, 1 to 5 for the radius. If the radius is 1 to 5, what do you think the sides has to be?
1 to 5.
All right, can I do this? I think so. If this is 3, what would that have to be? Yeah! And then when you're comparing, you would have to check both of them. So if they gave you both of them, you would just write over here, all right, compare 3 to 15. Does that really simplify to 1 to 5?
Yes.
Then you can say, yes, they're similar. Do you remember the symbol for similar though? Where I taught you. Yeah. The do-do-do-do. I don't know what to call it. Similar. So if you don't feel like writing out similar, feel free to use the do-do-do-do. Probably got it someday. I just wanted it. Okay. What about, let's test you. Well, actually, look at these ones. Do you think they're similar?
Yeah, they are.
Maybe. Yeah.
No. Yeah, because the smaller one.
Be careful with this.
No, because that's the diameter, so yes, they are.
Tricky, right? Why did that be so tricky? Okay, we'll come back to that. Don't stress. Here we go. Are these ones solid? Excuse me. Are these ones similar solid? You have to check every single side. So letter A, you got to compare. Well, look, 5 to 3, right? 5 to 3. So far, is it similar?
Yeah.
All right, but then we have to compare 8 to 6.
No.
I like to write them as fractions. Wait, is a fraction really a ratio?
Yes.
Totally. Yes, no? Are those two equal?
No, they're not.
All right. I'm hearing some people say no, it doesn't simplify to the same thing. So it's 5/3 equals what? Are those equal?
No.
All right. What if you're not a fraction person and you're not so hot at simplifying fractions? What are you going to do? What does this little symbol mean?
Divide.
Do it. Divide it. Type in 5 divided by 3. Anybody? 1.67. Do 4 divided by 3. Is it 1 point? All right, are those the same? No. So final answer? Not similar. Yeah? Okay, next one. Are those ones similar?
Yes.
All right, what if it asks for the ratio?
2 to 1.
Oh, question for you. I heard both. I heard the ratio is 2 to 1 or 1 to 2. Do you think it matters?
No. Yeah.
No, it doesn't. I hate that. I hate when it's misleading in the directions. Usually it'll say compare larger to smaller. So you know 2 to 1 or smaller to bigger. 1 to 2. Either way, it works. Okay, question though. Now it says compare the volumes. How are you going to find the volume of this one? Capital B times H. Base times height. Do it. 10 times 6 times 14. All right, 10 times 6 times 14. Raise your hand, help me out. What is it? 840? Okay. Now it's 840. What about the little guy? 105? Do we agree with Christian? Oh, sorry. Do we agree with Brett? All right, compare them. Here's, grab your calculators. I'm not positive this will work. Do 840 divided by 105. 8? Huh. much bigger is this? Okay, we're gonna come back to this one. I'm gonna show you something. But let's decide whether the two are similar. On the cones you have to compare everything. So compare the radius, compare the height. What do you think about number one? Do you think they're similar? No. Radius to radius would be 3 to 5. Height to height would be 4 to 10. Simplify the 4 to 10, that's really just what? Alright, 3 to 5, 2 to 5. Are those the same? Not similar. Oh, see? I told you. This picture came up. This picture again. This 5 is misleading. We don't want 5, we want 2.5, right? Okay, so radius to radius, that's 2.5 to 5. Do you see, you with us, Mood? Do you see something going on right there?
That's half.
From here to here, it's half. So then compare the other one. 7.5 and 15. What do you think? They're equal. So we can put yes, similar. How many of you feel pretty confident about that? Whether it's similar or not, we're doing okay? Easy. Okay, here's the big thing for today's concept. Copy down that I want to make sure you understand. Because it makes stuff so easy. It's like too easy. Alright, so start with this side. The scale factor is just side to side, but simplify it. If it ever asks for you to describe the ratio of the areas, you just take the sides and you square them. If it ever asks you to compare the volumes, all you do is take the sides and cube them. So rather than bother with finding the surface area and then comparing, or bother with finding the volume and then comparing, you can just use this simple here. It's super, super great. Alright. Okay, so off to the side. Let's just do a rectangle. And a bigger rectangle. But I guess this is solid, so let's make them 3D. I'm getting so good at this. Alright, solid. Yikes. I should say I'm getting better, maybe not good. Here we go. If this side is, how about 4, and this one is 16, you can figure out the ratio of just the scale factor, the areas, and the volume without dealing with finding everything all at once. Okay, so scale factor, let's do that part first. Scale factor, you just take the sides and compare them. So 4 to what? But you always want to simplify, guys. What do you always want to do? Simplify. It's a lot easier if you always simplify. So what's 4/16 simplified? Okay, so that's the scale factor. If it ever asks for scale factor, it's just the ratio of the sides simplified. Okay, then maybe it'll ask you for the surface area. Now I know it's going to happen, but I'll try to catch you when you're working on your assignment. People are going to be bothering, like finding the surface area, wrapping the present. Don't bother, because what's going to happen when you find the surface area ratio, once you simplify it, you can just use this. Take this from the theorem, what do we do to both of them? Yep, so start with 1/4, but to find the ratio of the surface area, square them. Again, you can find the surface area of one, surface area of the other, and then simplify it. You'll get 1/16, but this is way faster. Okay, volume. Volume, take the scale factor, but do what to it? Cube it. Do you know what 4 cubed is though? Is it 64? Yeah. Okay. Huh? Okay, let's put these to use. Okay, here we go. We're given the scale factor 2 to 5. Scale factor is just comparing the sides. It's 2 to 5. And then it says find the surface area. Okay, stop. Right here, surface area. Okay, so find some room and just put SA. To get the surface area, take the 2 to 5 and do what to it? Square it. Alright, so we've got 2 to 5. We have to square it to get the ratio of the surface area. Okay, you with me so far? Okay, no problem. Let me change up the colors. It then says the surface area of the cylinder A is 96 square feet. Cylinder A, is that the smaller one or the bigger one? Okay, you want to know that because what we're going to do, we're We're going to take this 4 out of 25 and set up a proportion. That's going to equal something over something. Yeah, put the 96 pi somewhere. Do you think it goes in the numerator or the denominator? You all said numerator, but how do you know? It's the little guy. We've got small 4, 25 bigger, so put 96 pi here. Be nice to yourselves. Just leave it in terms of pi. Okay, grab your calculators. Do you remember how to solve proportions? Cross multiply. So do 25 times 96. And then what do you do with the 4? Divide by 4. Alright. 96 times 25 divided by 4. 600. Yeah, we did pi. So cylinder B, surface area, 600 pi square feet. Okay, did I lose anybody on that one? That setup? Let's do volume because it's the same thing, only we cube. Alright, here comes volume. So volume, go back and start with what? 2 to 5, because that's the scale factor. They should already compare the sides for us. 2 to 5, but what should we do to that 2 to 5? Cube it. 2 cubed, 8. Okay, perfect, perfect, perfect. Alright, Alex, you getting this? Okay, here we go. Now that you know the ratio of the volumes, you can set up a proportion. So right here, it says the volume cylinder A, 128. So let's do 8 over 125 equals, where does the 128 pi go? Alright, I heard bottom first. Is it bottom or top?
Bottom, because it's the bigger cylinder.
It's the smaller cylinder, right? So let's put it in the numerator. 128 pi. Because let's be nice to ourselves again. Just leave it in terms of. Alright, so cross multiply. 128 times 125. What do we do with the 8?
Divide by.
Yep. Divide by 8. 1,000. Oh yeah, shoot, I forgot pi. Thank you for saying that. 2,000 pi cubic feet. Okay, you have a whole section of your assignment today that's just this. So let's review the process. Start with the sides. Make sure this is simplified because it makes your life a lot easier. Start here, find surface area. What do you do with this? Perfect, and then set up a proportion. Yeah? To find volume, start here and do what to it? Cube it, and then set up a proportion. You okay? Yeah? Okay. This one. The two codes are similar. Find the scale factor. Oh yeah, I kind of dorked this up in the morning class. We made it really hard, and it did not need to be that hard. Okay, so this one, let's just go small to big. So the ratio of small to big is 108 pi to 256 pi, right? No? We okay? We're just comparing it, setting up a ratio. Well, that equals the sides cubed. Do you agree with me?
Yes.
So it's like we have to go backwards from that. Okay, first off, what's going to happen with your pies?
They're gonna disappear.
Okay, those are gone. That's going to help. Those are gone. So now we have 108 over 256. Okay, here's what we took time doing. We did, well, how do you get rid of a cube? You decubify it. You cubed root it. Now, it got messy. Here's what I totally suggest, because I've been saying it all through the lesson. Start here. What can we do with this before we do anything else? Simplify it, because do you know how to simplify so quick on your calculators?
Yes.
Do it. Let's simplify it first and then do cube root. Alright, did you hear Gaden? He said this simplified is 27 over 64. Then you cube root it, or maybe you can do it in your head. You gotta think what times what equals 27. Yes! You guys are good, Tyler? 3 times 3 times 3 is 27. Alright, we actually did this already on our notes. Something times something times something equals 64. 4. It is 4. That's it. That's the scale factor. Not too bad?